I'll say it up front. Elon Musk is a 21st century Henry Ford, and Project Highland will launch an exciting new automotive revolution that very few are expecting. Once I realized the extent of what's coming, I stopped caring whether there's any demand for Tesla in China or in Timbuktu, because the rules are about to be rewritten. What worries me more is how OEMs will survive, because they're still aiming at yesterday's Tesla, while Tesla is about to go plaid. This moonshot is unabashedly optimistic, but it isn't just talk, because it's the engineering analysis that convinced me that second place may soon need a telescope to see Tesla. I really am serious. Hey guys, welcome to Connecting the Dots, the channel where we try to predict where disruptions will take us. In this video, we will do just that, as this is the first in a series of 2 or 3 videos analyzing Tesla's Project Highland. The current video cracks giant Easter eggs and tries to determine Project Highland's real goals and what they mean to the future of Tesla. And the next video will provide an engineering analysis of the project. I'll dive into the exciting technologies and innovations which Project Highland will use to achieve its goals. To get notified when the second video goes live, please subscribe to my channel and hit the bell icon. I fully respect your time, so I'll start with the bottom line. Most articles say that Project Highland's goal is to update Model 3 to Model Y's manufacturing methods by adding twin GIGA castings and a structural pack. These articles are living in the past, because Project Highland is not Model 3. It is Tesla's latest prototype for the machine that makes the machine, and will introduce manufacturing methods and technologies that will leave even Model Y's production in the dust. Model 3 is the guinea pig on which the production line will be tested and perfected, before Tesla starts using it in massive scale on its real money bringers. In time, Tesla will use versions of this production system on all cars from Model Y down, and at least some technologies on larger cars. And while all that is further down the road, Model 3's transformation is right around the corner. Production costs should take a dive much sooner than people expect. This was the bottom line. And now buckle up and get ready, because Tesla is about to unleash a huge disruption. And any project innovative enough to even disrupt Model Y is never boring. In the intro, I usually say that if you like my videos, please consider supporting me on Patreon, where you will also get my patron-only newsletter. Your support really helps. But this month, the tailwind that patrons give me takes on a whole new meaning, because the idea for this video came from one of my patrons, Scott M. Scott sent me the following message. I noticed an interesting parallel between 1913 Ford's Highland Park manufacturing plant and the naming of Tesla's Project Highland. He then added a few points from Wikipedia, which we'll see later in the video, and ended, "Coincidence? I think not. Also, if you haven't read the book Fordlandia, you might want to check it out. Hard not to see Elon as a modern-day Henry Ford in many, many ways." Remember, chairs are underappreciated? Elon just loves Easter eggs, and having read what Scott sent me, there was no doubt in my mind that Project Highland is just that, a giant Easter egg waiting to be cracked. I shot Scott a message congratulating him for the find, rolled up my sleeves, and started digging. Very little digging was required before I started seeing a plethora of hints on what Tesla's trying to achieve. It was eye-opening to say the least. The first Easter egg, Project Highland. So the first Easter egg we'll discuss is the project's name. Let's return to that Wikipedia piece that Scott quoted. On October 7, 1913, the Highland Park Ford plant became the first automobile production facility in the world to implement the moving assembly line. The new assembly line improved the production time of the Model T from 728 to 93 minutes. And the price of the Model T from $700 in 1910 to $350 in 1917, equivalent to a drop from $20,360 to $7,400 in 2021, which made the Model T affordable for most Americans. Massive reductions in both production time and costs are exactly what Project Highland's all about. In truth, Ford's Highland Park factory introduced tremendous innovations in manufacturing, some of which the industry managed to forget, until Tesla and Elon came along. Studying them reveals hints on where Tesla's going, so let's take a closer look and draw the analogies to Tesla. To understand Highland Park, let's first listen to Tony Seba.
This is New York City in 1900, Easter Parade. There is one car in this picture in a sea of horses. We used horses as our main means of transportation, all of humanity, for thousands of years. There is one car in this picture there. In 13 years, there was one horse in that picture. Can anyone see it? Essentially, transportation flipped from all horse, -1, to all cars, -1, in just 13 years. 13 years. And this is more than 100 years ago. And as you know, technology is changing even more rapidly now. And this is how quickly disruptions happen. 13 years, that's all it took. If you had invested in a horse barn in 1900, basically you lost all your money.
In the early 2000s, Elon Musk realized that once EVs arrive, they will quickly disrupt the entire auto industry. Following this realization, Tesla set out to build giant gigafactories designed to produce more batteries than the world's ever seen. Go back a century, and in the early 1900s, Henry Ford similarly realized that automobiles will soon disrupt the entire horse and carriage industry, and that a market for millions of automobiles is about to emerge, faster than anyone expects. A period of huge growth was about to start, and Ford knew that whoever acts first and grows fastest should dominate the market. Building cars, however, was a slow and labor-intensive process, in which each car was built by a team of workers who completed all tasks sequentially, start to finish.
Initially, they sort of bring all the parts together, numerous workers, it coalesces into a vehicle in place.
So it's like a team of people all working on one car.
Absolutely. They're trying to find ways of building these cars more quickly and more efficiently and more cheaply so you can drive the cost down.
Right, because I'm thinking a group of people getting together to build a car doesn't sound that efficient.
No, it doesn't. There's a lot of choreography involved.
Like I'd be running over and
got a
grabbing a wheel,
right,
putting that on.
Putting it on here, and maybe you're doing the muffler too.
And then a muffler.
But not that wheel, because that's my wheel.
Unless things drastically changed, building the millions of cars which Ford imagined would have required an impossibly huge workforce. But even this was theoretical, because the high cost of production limited the market for the cars to a small slice of affluent buyers. Note that there were cheap cars at the time, but the cheap ones were small and not utilitarian enough to appeal to most buyers. Ford realized that to reach the millions of sales he imagined, he would need to design a car which was useful and reliable, yet could be mass-produced efficiently, economically, and quickly enough to be inexpensive enough for the average American to own. The only way to achieve this was by disrupting the very way cars were built. Enter Model T, which Ford built in a brand new factory in Highland Park. Production started in 1909 using conventional methods, but it was 1913 when the fun started. The analogies between the early Ford Motor Company and today's Tesla are astounding. Just like today's Tesla, in the days of Henry Ford and Model T, Ford was an innovative, lean company that approached manufacturing through first principles and science, and wasn't afraid to risk everything betting on bold new technologies. I don't want this to be a history video. It's the future I'm interested in, but the analogies I found were too big to let go. So here's what I'll do. I will now show major analogies between Tesla and the early days of Ford. Some of these analogies completely stunned me, so I do recommend that you stick with me and watch. However, if your time is short and you just want what I have on Tesla's future, skip forward to the section marked with an arrow and called Recap on Highland Park. Back to the analogies. The assembly line. In 1913, Ford introduced the moving assembly line, an innovation which completely transformed the entire auto industry. Ironically, Ford's assembly line was inspired by the meatpacking industry's disassembly line, where carcasses hanging from an overhead chain moved from one butcher to another, each of them expertly performing a single action again and again. The moving assembly line, which was developed by Ford's chief engineer, Charles Sorensen, and implemented under the guidance of Henry Ford himself, consisted of a series of conveyor belts and other mechanical devices that moved the cars along a production line as workers performed their task. Each worker was responsible for completing a specific task, such as attaching a particular part or component to the car, and then passing the car down the line to the next worker, who would perform the next task. This division of labor allowed Ford to significantly increase the speed and efficiency of its production process. Going from over 12 hours to 93 minutes is a whopping 87% reduction in assembly time, and this talk of production time rings a bell. Remember how VW's then CEO, Herbert Diess, said that it takes VW 30 hours to build an EV, and that they're going full speed ahead to reach Tesla's 10 hours in a few years? So first, let's not compare these 10 or 30 hours to Model T's 93 minutes. Different cars, different regulations, and most of all the times given probably cover different stages of production, And let's put aside the fact that without Deese VW's chance of reaching this 66% reduction anytime soon are slim. But even if they do make it in 2 years or so, by then, Tesla will be much further ahead than that. Interchangeable parts. Besides pioneering the moving assembly line, Model T was also the first car to be built using interchangeable parts. Using these was a key innovation that helped to make the Model T affordable and widely available to the public. Prior to the introduction of Model T, most cars were built by hand, and each car was unique, with parts that were custom made for that specific vehicle. This made cars expensive and time-consuming to produce, and it also made it difficult to repair them when they broke down. The Model T, on the other hand, was designed with interchangeable parts in mind. This meant that almost any given part could be used on any car, which made it much easier and less expensive to produce and repair the vehicles. The use of interchangeable parts also made it possible for Ford to increase the speed and efficiency of its production process, further reducing Model T's cost. I said almost all parts were interchangeable because some, such as the engine and transmission, were more specialized and required more precise manufacturing tolerances. In these cases, the parts were still designed to be as interchangeable as possible, but they may not have fit perfectly on all Model T vehicles. 100 years have passed, and interchangeable parts are now the standard that everyone uses. Tesla's using interchangeable parts is nothing to write home about, so why am I even mentioning it? Simple, because Tesla took this notion to the extreme and made entire sections of the chassis interchangeable. For the latest Model Y, take any front casting, any rear casting, and any battery pack, attach them together, and presto, you have the lower chassis. Optimization and scientific management. The moving assembly line and interchangeable parts made production faster and cheaper, but these huge savings weren't immediate. Model T production in Highland Park introduced another innovation in the application of scientific management principles to car production. These ideas were developed by Frederick Winslow Taylor and focused on finding the most efficient way to perform each task in order to reduce waste and increase productivity. Taylor developed a number of principles and techniques, including time and motion studies, which involved analyzing the movements and actions of workers to identify ways to optimize their performance, standardization of work, which involved establishing clear rules and procedures for each task, and the use of specialized tools and equipment which were designed to make tasks easier and more efficient to perform. Taylor's ideas were so groundbreaking that his 1909 book, The Principles of Scientific Management, was voted almost 100 years later as the most influential management book of the 20th century. At the time, these ideas were truly cutting edge, yet Ford was quick to implement them at the Highland Park plant. Each step of the production process was analyzed and optimized, and the process was gradually honed and improved. Ultimately, production consisted of 45 small, specialized tasks that could be completed quickly and efficiently by individual workers, and together enabled Ford to assemble a Model T in 93 minutes. Tesla is similarly obsessed with optimizing the product and its production. As Joe Justice told us, Tesla reinvented the production line and turned it into an array of modular cells, which enable it to open parallel stations in which they test, modify, and optimize parts and production methods in real time, without disrupting the main production flow. This enables Tesla to make 3 changes per day, or 1,000 per year in each of their models. Looking from the other end, teardown titan Sandy Munro is awed by what he describes as Tesla introducing change at the speed of thought, faster than any other OEM.
We're looking at nothing short of advancement after advancement after advancement. Nobody I've ever heard of could make 13 changes in less than 3 months. This is like staggering. How do they do that?
To highlight how Tesla is more like the early Ford than current-day OEMs, consider this. Current OEMs introduce a minor refresh every 2 years, and a major one at 4. But in the span of 5 years, Ford went through 20 major redesigns of Model T in its production line. Early mover companies run by an owner-founder tend to move fast, while complacent companies run by MBAs tend to delay change. As Darwin taught us, only those who can change survive. Pure genius, train station to workstation. Tesla's obsession with improving the process can be seen in GIGA Shanghai's design and that of all factories after it. The factories have truck bays lined along it, where trucks drop containers full of supplies right beside the production line stations which use them. This shortening of distance and actions between truck and production station is pure genius. The thing is, it was Ford's genius that Elon revived, and when I saw this, it blew my mind. With space at a premium in the urban area of Highland Park, the factory's main building was 6 floors tall. Bringing supplies and removing scrap from upper floors seems like a nightmare. But take a look at this. Looking at factory plans, we see loading docks for trains alongside the building. Now listen closely to how it worked.
The trains came in, all the tracks were behind me, and the trains would come loaded, and then the crane would follow across the top, and the crane would reach down onto the train, into a car, and pick up the equipment that was needed, the crane would, and then deposit them in the buckets that are here. The workers there would then take the equipment that they just received, turn around and be able to assemble right behind them on the assembly line. So it's really a unique distribution system of getting the pieces that were needed to the assembly line, which is really back behind this wall here.
So a train arrives, an overhead crane unloads it and drops the supplies right beside the production line station which uses them. That's it. This is pure genius performed over 100 years ago, when Ford was still lean and mean. As Ford grew fat and complacent, they forgot these early lessons, and it took many decades and outsider Tesla to remind the industry that the best warehouse is no warehouse, and that products should arrive right where they're used. Any color you like. The BMW 3 Series is offered in a variety of 11 colors. More down market, the Toyota Corolla offers a variety of 8. Tesla, however, offers all of its models in the same 5 colors, and when just launching a model, they offer it in only 1 or 2. The reason, of course, is efficiency, as it is much more efficient to run entire batches of cars in the same color without switching the paint shop to another. Similarly, Henry Ford famously said, "Any color the customer wants, as long as it's black." And this too was for efficiency's sake, but with a surprising twist. Once Model T production ramped up, cars came off the line in 3-minute intervals, or 6 feet per minute. The 93-minute production time was so fast that paint became a bottleneck, and only Japan Black would dry fast enough. This forced Ford to drop the variety of colors available before 1914, and adopt a one-color policy until fast-drying Duco lacquer was developed in 1926. In both cases, reporters and experts said that limiting colors would limit their markets. But since both companies were supply constrained, they chose to do what enabled them to make more cars, rather than follow conventional wisdom and create even more demand while increasing costs and lowering supply. Long term, I see this as very smart. Shortening supply chains. Tesla always tries to localize and shorten the supply chain wherever it sets factories, and the localized supply chain is an important factor in GIGA Shanghai's success. Ford saw similar importance in having their suppliers close by. In fact, the Highland Park plant itself was set up 4 miles away from the factory of Ford's main suppliers, the Dodge brothers, who provided precision engine and chassis components for the Model T. Using the best parts. Spark plugs in gasoline-powered internal combustion engines operate via precisely timed high-voltage electrical current. In early cars, this was performed via a magneto, a device in which magnets rotated inside a coil, with their magnetic fields forming sparks. Magnetos were usually driven via a belt or chain connected to the engine's crankshaft, but belts and chains sapped power and had maintenance issues. With Model T, Ford removed the need for belt or chain drives by connecting the magneto directly to the crankshaft. Ditching the chain drive not only made their car more reliable, but also reduced parts count, simplified assembly, and made the car cheaper to make. This is just one of many examples where Model T construction took the best part is no part and the best process is no process approach that Tesla has in its vehicles. GIGA castings. Tesla isn't the first automaker to use castings. Many OEMs did so before them, but Tesla was the first to dream bigger and dare tackle the technological hurdles required to make castings as big as their mega castings and giga castings. Over a century before that, Ford was the one that dreamed largest.
They did a completely new engine.
This was the first single block 4-cylinder engine, 20 horsepower, very, very peppy.
It had a separable cylinder head.
So much easier to work on. Every Model T was delivered with a set of tools, and you were expected to learn how to repair your own car.
You could undo the bolts, take the cylinder head off. There were the valves, there was the head. You could do the maintenance, put them back together, and go on your way. That's the way every internal combustion is now. In 1907, hardly anybody was doing that. It was really difficult to do. They managed to pull it off So it was a big selling point. Model T's predecessor, the Model N, had an engine block cast in 3 pieces, which was heavier and more difficult to assemble. The result was that the Model T was a lightweight car, used less material, gave good performance, and was a great value.
So Ford was the first to have cast an entire 4-cylinder engine block, and the importance of this feat can't be overstated. While Ford's competitors cast each cylinder separately and then had skilled workers align and bolt them together, Ford's monoblock casting was much faster, did not require costly skilled worker time, and without the tolerances involved in manual bolting, produced a superior product. It even had less threaded fasteners. Shout out to Sandy Munro. And it doesn't even stop there. A few videos back, I mentioned a motivational book that completely changed my life, Think and Grow Rich by Napoleon Hill. There's a link in the description. The following paragraph about the 1932 Ford V8 is taken from that book.
When Henry Ford decided to produce his famous V8 motor, he chose to build an engine with the entire 8 cylinders cast in one block. Ford instructed his engineers to produce a design for the engine. The design was drawn up on paper, but the engineers agreed to a man that it was simply impossible to cast an 8-cylinder engine block in one piece. Ford said, "Produce it anyway." But they replied, "It's impossible." "Go ahead," Ford commanded, "and stay on the job until you succeed, no matter how much time is required." So the engineers went ahead. 6 months went by. Nothing happened. Another 6 months passed, and still nothing. The engineers tried every conceivable plan to carry out the orders, but the thing seemed out of the question. Impossible. At the end of the year, Ford again checked with his engineers, and again they told him they had found no way to carry out his orders. "Go right ahead," said Ford. "I want it, and I'll have it." They went ahead. And then, as if by a stroke of magic, the secret was discovered. The Ford determination had won once more.
Ford's big breakthrough is to cast his V8 engine as a single unit. Other manufacturers were producing V8s, but you'd have the crankcase down at the bottom and then the cylinders as separate pieces, so you could have 3 different pieces in this. More pieces means more production, more people, more cost. Ford got rid of all of that by casting the whole thing as a single unit.
What's with the Swiss cheese design?
All of these holes are your cylinders. Your piston would go inside there.
The monoblock V8 was a hard feat to achieve, but this made mass production significantly faster and cheaper, while making the engine itself almost bulletproof.
A guy called me up one day and he goes, "I got a Model T in my bag. I'm never going to store it. It's been leaning against my shed for 45 years. So we dragged it over here, you know, and okay, of course the gas tank was all rusty, but
right.
I poured gas in the carburetor, pulled the handle twice, and it fired with no battery, right over it with the...
That's incredible.
Yeah, I mean, so they, you know, this was the iPhone of the day. It was so far superior.
The Ford V8 was a huge seller, powering Ford automobiles from 1932 to 1953, and 90 years after its arrival, it still has a following among hot rod fans. Things move faster now, but I can envision a museum or art gallery displaying the exposed chassis of a double Giga castings and structural pack Model Y, with a sign beside it, "How it all began." And here's a teaser for you. If you like Giga castings, you'll love the upcoming engineering analysis video, so make sure to subscribe and hit the bell icon. State-of-the-art factory. All these points resulted in the factory being, for the time, truly state-of-the-art. This didn't stop at production methods, as the layout of the factory itself was also unique. We already described loading docks, trains entering the factory, and cranes unloading their supplies directly to the production line station which needed them, but the factory also included its own foundries, waste management, and power generation. Moreover, the factory was designed with large windows and skylights to provide natural light, which was so unusual for factories at the time that people referred to the factory as the Crystal Palace. The factory also had an advanced ventilation system that helped improve working conditions. A century has passed, and most factories have internal power backup, waste management, etc. Tesla's factories, however, remain in the front of the pack, as their roofs are being covered by solar panels, which along with battery storage should enable the factories to largely operate on renewable energy. And similar to the Crystal Palace, Giga Austin is renowned for its huge panoramic windows and letting the sunlight in. Ivory, sweat, and grease towers. GM's headquarters is located in the Renaissance Center in Detroit, Michigan. The headquarters are at the Detroit Marriott, the largest of the complex's 7 interconnected skyscrapers. Ford World Headquarters Complex in Dearborn, Michigan is less impressive, But in 2016, Ford started a decade-long project of building a new, high-tech headquarters campus that should rival and pass GM's. Both companies' headquarters are mostly used for management and administrative purposes, with the closest R&D centers and closest manufacturing plants a few miles away. In 1908, however, Ford's headquarters and R&D were both located in Ford's main factory, the Highland Park plant. When Highland Park was superseded by a larger factory, headquarters moved there. Ford separated its headquarters from production and R&D in the early 60s, a great boom period for the American car industry. Give managers a few years in these ivory towers, and we all know how prepared they were for the 70s and beyond. Similar to Henry's Ford, Elon's Tesla had its headquarters at the Fremont factory and recently moved them to the Austin factory.
The internet is aghast and maybe even agog at the couch Elon Musk sleeps on when he works late at Tesla. He showed us the couch during an interview last week at his Silicon Valley Model 3 car factory.
Last time I was here, I actually slept literally on the floor because the couch was too narrow.
Yeah, I was going to say. And Elon, I have to say, it's not even a comfortable couch either.
No, it's terrible. This is not a good couch.
What does the number say?
After seeing that report, a California man was moved to start a GoFundMe page called Buy Elon Musk a Couch. In one day, the campaign raised more than $5,000.
Tesla insists that all factories should include R&D, and availability of skilled engineering talent has been a factor in choosing locations for all Gigafactories following Giga Nevada. Recap on Highland Park. Ford's Highland Park factory was Ford's first factory, and Model T, Ford's first car, that were explicitly designed for mass production. The factory started producing Model Ts using conventional methods, but then introduced the first automotive moving assembly line. Ford used innovative scientific management methods, with constant iterations and optimizations of the car and its production process. Ford's almost obsessive optimization introduced new innovations such as interchangeable parts, huge castings, and a deletion of parts. All this slashed production time by 87% and production costs by 50% and made the factory safer. All this goes well with Tesla's approach of continuous improvement, as well as their recent announcements on making their next platform 50% faster to build and 50% less costly to make. We'll dive into this soon, but before we start solving the puzzle, we must first add a few more pieces from Ford. Giga Rouge. As production grew, Ford's factory proved too small to handle the number of Model Ts the market demanded, and although a few branches were formed, they still weren't enough. Besides, constricted by its urban location, Highland Park's main building was 6 floors tall, which made production less optimal and restricted subsequent changes in the line. Ford needed a new factory, so it drained swampland in River Rouge, Michigan, built an unprecedentedly huge, ultra-modern factory, and moved its headquarters there. Unencumbered by urban space limitations, and built using Highland Park's lessons, the new factory was Highland Park on steroids and took production efficiency to the extreme. To get a better idea of Giga Rouge, let's watch this short clip.
Henry Ford then began massive expansion at the Rouge. Building after building after building followed after World War I.
Raw materials would float up the river to a mammoth single-level facility where they could be forged into steel, smelted into iron, milled into frames, molded into tires, and melted into glass. All these components would move directly to the assembly line. Ford wanted to go from raw materials to finished automobile in 2 days.
He put his dream into practice. He was going to change the way that manufacturing took place.
He risked his business building River Rouge. This was a huge bet.
Highland Park had trains coming in and out. Giga Rouge had that and boats. Highland Park had vertical integration. Giga Rouge took that to a max, bringing iron ore from Ford's own mines and rubber from Ford's own plantations, and spitting out cars at an unprecedented pace. Highland Park had waste management and recycling. Giga Rouge went all in, recycling whatever it could from turning sawdust into coal to melting entire Model T chassis. I'm sure you noticed the many similarities between Ford's River Rouge and Tesla's Giga Austin, so let's go on. Tesla's goals. Enter YouTube and search for Tesla Project Highland, and you'll get several videos discussing the upcoming Model 3 update, usually saying it's designed to reduce costs and bring Model 3 up to date with production methods of the latest Model Ys. These videos are right. After all, Model 3 was Tesla's first attempt at making a mass-market car, and although significantly changed from its inception, production is far behind that of its Y sibling. Berlin and Austin Model Ys have front and rear GIGA castings and a structural battery pack, with or without structural 4680 cells, while Model 3s don't even have rear mega castings. Remember these? Prototype machine that makes the machine. I fully agree that bringing Model 3 to Model Y's production methods would update it a lot. The thing is, I think Project Highland is much more than just that. To explain why I think so, listen to this.
The Highland Park plant was the plant where Henry Ford perfected the assembly line. A Model T is rolling off the line every 30 seconds or so.
The idea of the Model T was that if you made enough of them and made them efficiently enough, then anyone could afford one. And of course it worked. The automobile industry became the engine of American industry.
300,000 Model Ts were built in 1914, but the forecast was over 2 million.
So Ford had to figure out how to build more cars, a lot more.
Now listen carefully to the next sentence.
The Highland Park plant was really the prototype, the model for a plant that was thought of as a machine in and of itself, a machine for making machines.
Highland Park isn't the name of a car, or of a Model T upgrade program. It was the factory which Ford used as a prototype for perfecting the machine that made the machine, and optimizing it for mass production. Once production time was shortened and costs were slashed, Ford implemented the system in massive scale in Ford's giant River Rouge plant. Similarly, I believe that Project Highland isn't the code name of some upgrade program, but that of Tesla's prototype program for a future platform built using a breakthrough production method. Sure, Model 3 is Tesla's guinea pig for this system, and sure, it'll be upgraded with all the latest production goodies which Model Y has, but that's just for starters. Project Highland should have many other production breakthroughs, some of which I'll describe in my upcoming Project Highland engineering analysis video. Elon loves historical symbolism, and is an avid follower of Ford in its early days. Forget the zillion analogies I stated above, just looking at Tesla's model names confirms that Elon peeped into Ford's early history and liked what he saw. With all the symbolism the Highland name carries, I'd be surprised to learn it was used for just updating Model 3 to Model Y standard. Ford's Highland Park reduced Model T's price by 50%. Elon said they want to reduce the cost of Tesla's next platform by 50%, and Model 3 is the precursor of this new world. Project Highland is a prototype for the machine that makes the machine, a project to form a new platform for the new Model 3, and then optimize and re-optimize it for cheaper and faster production until it's ready for prime time. And by prime time, I mean Model Tau. In the Q2 22 earnings call, Elon said the following.
At this point, we've done the engineering for Cybertruck and for Semi, and so well, obviously you can guess what we're working on, which is the next generation vehicle, which will be probably about half the cost of the 3Y platform. It'll be smaller, to be clear, but it will, I think, swiftly exceed the production of all our other vehicles combined.
Yeah, I mean, obviously, we're going to take everything we learned from SX, 3Y, Cybertruck, and Semi and pour it into that platform. But we, as you've said to us many times, we're on a 2-for-1 target. So,
yeah,
that implies that trying to get to that 50% number again.
Yeah, that's exactly. It's like what would it take to. That's exactly what Lars describes. Is what we're trying to figure out. How do we make 2 cars for the amount of effort that it currently takes us to make 1 Model 3?
The Highland model should significantly slash costs and time, but Model 2 will use that platform to bring costs down to an amazing 50%. I see 2 reasons for Model 2 being growing from Highland. The first is symbolic. Highland Park produced Ford's bestseller, the Model T. And although a less expensive Model 3 should sell in huge quantities, Model 2 is the one planned to be Tesla's real bestseller, their everyman's car, their Model T. And the second reason is that if Tesla develops and optimizes for Model 3 a process and platform for making cars cheaper and faster than ever before, Model 2 will probably use that platform, perhaps slightly modified. It's also probable that the 2 will use its own platform based on Model 3's insights. However, the possibility that Model 2 won't take part in the Highland Fund seems very unlikely. And here's a moonshot. Tesla can't call it Model T and won't call it Model 2. But what if they use a Greek letter and call it Model Tau? This is just a wild guess, but somehow it sounds right. Let me know below if you think Tesla will use this name for Model 2. And for a really wild guess, if they do call it Model Tau, chances are that the first batch will be delivered in black. High symbolism there with free worldwide publicity. The second Easter egg. So far, the discussion is focused on cost reduction, which enabled Ford and will soon enable Tesla to retain high margins while slashing prices and offering a car that most households could afford. An equally important aspect of Ford's Highland Park program, however, was reducing production time and producing cars at massive scale. Lowering price brought massive demand, but shortening production time enabled massive supply to meet that demand. Model T production grew until Ford produced over 2 million cars a year and sold 16.5 million Model Ts, a record that held until the 70s. I cannot overstate the implications of being able to produce cars on a massive scale, and here's where we get to the second Easter egg. Let's listen to Elon tipping us on Tesla's Secret Master Plan Part 3.
So Master Plan 3 is going to be fundamentally about scaling. Just looking at the overall problem from a global macroeconomic standpoint and saying, what are all the things that are needed to achieve a fully sustainable economy? Because I think a lot of people don't know. And really, like, what tonnage of lithium, of cathode, anode, separator electrolyte, electronics, what are all the things that are needed, what are all the things that need to be done in order to transition to a fully sustainable global economy?
Tesla's main focus will be scaling to extreme size, and with Elon discussing tonnage, mining, and refining, we all focused on batteries and energy. But instead of looking at how they get the batteries, let's look at what they do with them. Elon said that Tesla has started the ball rolling towards massive battery supplies, and that these batteries are intended for both vehicles and stationary, which makes it a double whammy. Massive amounts of megapacks from Lathrop and massive amounts of cars. Enter the low-cost Model 3 and ultra-low-cost Model Tau. I cannot underscore enough the significance that flooding the world with low-cost EVs has to Tesla and its mission. The third Easter egg. This final Easter egg is about timing. In October 22, Elon tweeted that the Boring Company started selling a new perfume, Burnt Hair. So sure, it's the Boring Company and not Tesla. And sure, it could be related to their not a flamethrower. But just about everyone on Tesla Twitter thinks it's about the shorts getting burnt again, and so do I. This was back in October, and we know Elon time, so I don't know if this should be this quarter or the next, but production of a new Model 3 using the new platform should begin soon. And since Model Tau shares the platform, it doesn't have to take 2 years to arrive. If they want to, Tesla could release it not long after Model 3, although they'll probably wait a while to let the 3 make a killing and gain new insights for updating production and platform. What next? Ford's Highland Park plant served as a prototype for improving production processes and optimizing the machine that makes the machine. It enabled them to reduce production time by 87% and cut production costs by half. Once production was crushed, Ford modeled its huge ROUGE plant using Highland's lessons and started spitting out cars at a pace the world has never seen. And this outpour of cars changed not only Ford, but the world itself. Similarly, Tesla are using Project Highland to improve Model 3's production process. They will soon start producing a new Model 3 based on their new third-generation platform. They haven't announced the new Model 3 yet because it would Osborne the hell out of current Model 3 sales and probably hurt Model Y as well. But once they show it, probably in the March investors call, production should follow soon after. This will probably happen in the huge GIGA Austin factory, which once ramped will start spitting out Model 3s faster than anyone expects. This could possibly happen in other factories as well. They won't reach a 50% cost reduction with Model 3, only with the smaller Model Tau, but I do expect huge improvements in both time and costs of producing Model 3 itself once production is ramped up. And once Tesla smooth, learn, and optimize with Model 3, they'll start making Model Taus and robotaxis. Tesla's factories will ramp up to extreme scale and will start spitting out millions upon millions of cars at a pace nobody imagines and transition the world to sustainable energy. If you think they won't have enough cells, I have 3 letters for you. LFP. Again, this is a moonshot. I'm connecting very faint dots and could very well be wrong. I just sniffed the air, noticed a certain scent, and shared what I think could be cooking. But before sharing it, I also checked the ingredients to see if Tesla could actually make the stew I described. The short answer is yes, and that's why I'm bullish. In the next video, I'll share an engineering analysis of the technologies Tesla could use to achieve the required savings. But for a sneak peek at some of them, watch my Cybertruck Technologies video. Until then, let me know what you think. Will the Highland Model 3 be the first to use a new platform, or will it just update Model 3 to Model Y production methods? When do you think will Tesla start selling Model 2, and when will they make robotaxis? Will Tesla call it Model Tau? What's your guess for a name? What savings will they achieve, and does the competition stand a chance? Let me know in the comments below. A huge thank you to my patron Scott M for giving me that lead on Highland Park. If you liked this video, please consider supporting me on Patreon for as little as $1 a month or as high as you wish. Your support really helps me make these deep dive videos, and you'll also get my patron-only newsletter. A huge shout out to my latest YouTube channel members, Marty, Vince D, and Alan B. And to my latest patrons, Dave Michigan, Bhavik J, Sean W, Stephen F, DC Heath, Ulf, David J, Timothy H, Steve D, Ann H, Helmet G, and Whiskey. And to all my patrons, you guys rock. Twitter is becoming the place to be, so I invite you to follow me there. I'm Connecting No Dots. I tweet several times a day with everything from long threads analyzing Tesla matters to making memes and hanging out with you guys. So, see you there. Until next time, I am Connecting the Dots, and you are amazing.